Many of the predicted impacts of climate change on the planet are bad, if not catastrophic. Melting glaciers, rising sea levels, more extreme weather. But what about the effect on diseases spread by mosquitoes? Will malaria become more common too? Scientific efforts to find out have thus far been oversimplified, and the results mixed. Now, using a sophisticated model incorporating hydrology, researchers say that while malaria may increase in some parts of the world, it probably won't in West Africa. Their models predict that the number of malaria cases there will largely remain the same, and in some places even decrease. Because malaria is a disease of temperature-sensitive parasites spread by climate-sensitive mosquitoes, environmental change can potentially shift the malaria burden up or down. For example, the malaria-transmitting mosquitoes in Africa prefer temperatures in the 60s to mid-80s. They'll die if it drops below 50 or goes above 95. Temperatures also influence the incubation period of the Plasmodium parasite. Plus, because mosquitoes reproduce in standing pools of water, rainfall can also have a huge impact. But the link between rainfall and malaria is more complicated than a simple one-to-one relationship. In West Africa, where more people are infected with and die from the disease than anywhere else in the world, the number and size of rainwater pools depends on rainfall patterns, as well as local soil, vegetation, and topography. Scientists spent several years doing fieldwork in 2 villages in Niger to collect information about soil moisture, water temperature, pool location and depth, and how mosquitoes interact with these pools. This allowed the researchers to develop and then test a new, realistic model of malaria transmission incorporating these factors. The model simulates the life cycle of mosquitoes, from biting humans and transmitting the malaria parasite to seeking standing water and laying eggs. The model also tracks human immunity to malaria, which builds up as people are bitten by infected insects. Importantly, the new model includes individual mosquitoes and their relationship with standing water, updating the status of the mosquitoes, human disease, and water every hour to create a virtual representation of malaria transmission. The scientists then used this model to predict whether malaria outbreaks will become more common or more severe in the future. With climate change, the western part of West Africa is expected to get drier. In the east, it will likely get wetter. In all places, the temperatures will rise significantly. So what does the model say? In northern West Africa, it's hot and dry. Although the region will see more rain, it won't be enough to allow mosquitoes to prosper, so climate change is unlikely to impact the number of malaria cases there. Similarly, in the south, temperatures will rise, but not so much that they put a damper on mosquitoes. Malaria is rampant there now, and will continue to be. Far western Africa, however, will see less rainfall and increased temperatures. Both changes work to hinder the spread of the disease. And because the region is usually near the threshold for a malaria outbreak, residents of these villages can expect fewer and less serious outbreaks. Finally, eastern areas are expected to have more rainfall, augmenting breeding. At the same time, higher temperatures will likely kill more mosquitoes. Here, the two effects cancel out, suggesting that the current rate of malaria will remain the same, despite changes to the environment. The results highlight the importance of building models with additional details based on careful fieldwork, and indicate that while many West Africans will undoubtedly suffer from higher temperatures in the coming years, more malaria won't be one of their problems.